Hey guys, welcome back to my YouTube channel. So for today's video, I will do a summary in chapter 5, which is Ethernet. So we have here the 5.1 Ethernet protocol, 5.2 LAN switches, and 5.3 address resolution protocol. So for 5.1 Ethernet protocol, we have here Ethernet is most widely used LAN technology today, defined in IEEE 802.2 and 802.3 standards. So we have a support data bandwidth here. So Ethernet operates in a data link layer and physical layer, which is an Ethernet, and then Ethernet relies on two separate sublayer of the data, which is logical link and the MAC sublayer. And then the Ethernet LLC sublayer handles the communication between the upper layer and the lower layer. It is implemented in software and its implementation. So we have a MAC sublayer constitute um, lower sublayer of the data link layer. MAC is implemented. So we have a data encapsulation media access control. So as you can see, we have here. And then data encapsulation provides the three primary functions. We have frame delimiting, addressing, and error detection. So Ethernet evolution. So since 1973, Ethernet standards have developed specifying faster and more flexible version of the technology. So early version of Ethernet slow at 10 Mbps. So latest operates at gigabits per second and faster. So we have a preamble, destination MAC address, source MAC address, Ether type, data, and FCS. So the minimum Ethernet frame size from destination MAC address to FCS is 64 bytes, and the maximum is 1518 bytes. So here, as you see, frame less than 64 bytes are called collision fragments or runt frame. We have here the um, lab exercise, and we have here the MAC address and hexadecimal. So as you can see, we have a decimal and binary and hexadecimal. So for the decimal, we have 0, 1 to 15, and then the binary, which is we have for 0. For the decimal 0, we have a 0, and then for the decimal 1, we have if you convert decimal 1 to binary, we have 0001, and then we have to decimal 2, we have 0010. So for the hexadecimal is the same, but if we longer with the number 10, we will include that we have A. If 11 is B, and then 13 is D, and so on. And then we have organizationally unique identifier for OUI. We have 24 bits, 6 hex digits, and 60 TF and Cisco. And then again, we have a vendor assigned NIC interfaces, 24 bits, 6 hex digits, and 3A07BC in particular device. So frame processing, the MAC address is often referred to as burn-in address BIA, meaning the address is encoded into a ROM chip permanently when the computer starts up, and the first thing the INC does is copy the MAC from the ROM into RAM. Do not include that. Unicast, as I said in the previous chapter. So unicast is MAC address is unique address used when a frame sent single transmitting. So as you can see in the figure, it has a single uh, transmitting device. For broadcast, it also all host host group will what do you call this, can receive the message for the source host. So LAN switching, switch fundamentals. So it's easy. So learning MAC address, switch dynamically build the MAC address table. The process to learn the source MAC address. So switches examine all incoming frames from the new source MAC address information to learn. So video demonstration MAC address. So switch receive the Ethernet frame, examine the source MAC address, and notice the MAC address snap is MAC address table, so it adds MAC address in the incoming port number. We have So as you can see, we have switches used on the following forward method of switching data between network ports. We have store and forward. Store and forward switch receive the entire frame and computes the CRC. If the CRC is valid, the switch looks at this destination which determines outgoing interface and frame the forward correct port. So cut through forward frame before it entirely receive. So this is the difference. So cut-through switching. In cut-through switching, the switch buffers just enough of the frame to read the destination MAC address. So port-based memory and shared memory. So full it is easy because half duplex and full duplex is we already tackled. So auto MDX, address resolution protocol. So destination on the same network are primary addresses assigned to the device Ethernet LAN, which is physical address, the Ethernet MAC address, logical address. So destination, remote network. Introduction of ARP. So when a device sends a Ethernet frame, it contains these two addresses, the destination MAC address and the source MAC address. So determine the destination MAC address. The device uses ARP. ARP provides two basic functions, resolving the IPv4 address to MAC address and maintaining a table of mapping. So the function here is define MAC address that is mapped into IPv4 address, and then video demonstrate ARP request is broadcast frame sent when a device needs a MAC address associated with an IPv4 and it does not have an entry of IPv4 and its ARP table. So as you can see, we have an ARP table here. On the Cisco router, show IPARP commands display the ARP table. So on a Windows host, Windows 7 PC, the ARP-A commands used to display the ARP table. So we have here lab. So ARP broadcast request received and processed by every device on local network. Spoofing is attackers can respond to requests and prevent the provider of services. It is attackers or hackers. So here's the chapter summary of the. So explain the operation of Ethernet and explain how switches operate. Explain how the address resolution protocols enable communication on a network. So it's done for the summary of chapter 5, and I hope you enjoy it, and thank you for watching.